There we go. Hello. Welcome to Before Basics Computing. Once again. Oh yes, over here. Yes, this is where I need to look if I want to look into the camera. We're gonna try to get a Hello World program working on this LCD here. And yeah. So I got my text editor open here. We're gonna actually first make a reference because I haven't done that yet. I've got I'll show you over here. I've got paper. Yeah. So what I have is I have basically the documentation for the processor right here. Right here. You see this? Probably can't see that. Let's we need to kind of organize it. Oh yeah, before I get too into things, I wanted to say, for those watching this back on YouTube, don't feel pressured into watching these unless you only watch these on as a VOD if you want to see everything from beginning to end. If you don't care, then just wait for videos to come out, because I will be condensing everything into much more understandable formats and shorter formats, because Hello World can probably be explained in 20 minutes or less, and it's probably going to take me 6 to 8 hours. So, yeah. Especially because I'm going to be creating this assembler thing. Oh, I'm in the wrong one. There we go. Especially because I'm going to be creating this reference for this assembly. Let's go ahead and grab the one that is... Where's the paper that lists all the instructions? Why not have that? Thought I had that. I guess not. Well, I do have another one that lists all the instructions, so we'll just use this one. This one's a little bit more in-depth. It tells you what the stuff does. So this one, we have add with carry. And this will... Wish I had somewhere better to put this. Woo! Okay, and this is why I want a quick reference on like 2 to 3 pages, so I don't have to have stacks of paper, unless if I'm needing to know something specific. Oh, I don't have to write a quick reference. I found my quick reference. So apparently, they thought of this and were nice enough, yeah, to actually make what I was going to make. And I didn't realize that. And they even have a memory quick reference. I don't know if you can see that, but that's the addressing modes quick reference. And then they have the opcodes quick reference for the instructions right here. Look at this. So this will go a little bit faster than I thought. You know what? Let me just switch over. um, writing a program. And the rest of this, I only need if I need something specific on how the addressing mode works or something like that. So this can all go. If I don't want to throw it, I'll just put it down here on the ground. Okay. I have some other references here. I have the. So we can watch this when we actually run the program. I have the cycle specific for every addressing mode and instruction. It tells exactly what each cycle should do. We can watch that here on the board. So we don't need that right now if we don't have a program. Program that's on there is just jump to itself. It's a one jump instruction. It's the longest program I think I've ever written. Yeah. Let's see. Oh, yep, okay. So we've got all this stuff. Tells you what the status registers are. I mean, this is just everything I could have wanted. So now we have to get a different reference. Right. So we got this reference. Can it be seen? Oh, probably not from there. But this is just an ASCII chart. I'll be using this for the LCD. Let's put this over here for now. And then I have keyboard scan codes, but we won't be using those right now. Here's the other one. I have the LCD screen command reference. You can find this online. Just showing that that's what I got. And yeah, there's another page. Another page. And this one. Maybe you can see it on there better. Probably not. So yeah. We got all that. We got this and this ready to assemble. So let's write out our program in kind of my version of assembly. We got to figure out what we got to do though. So let's maybe write out some pseudocode first, and just so we know what we're doing. So when we want to print a character, we want first thing, first we have to initialize the LCD. So that doesn't even matter. To initialize the LCD, we want to send let's see here, how do they do it? Okay, so I've got to flip all these because they have a most significant digit on the left, which is the easier way to read it. On the board here, it's, well, if you have it flipped correctly. Let me show you the one that's flipped correctly. That one. Here. This one I have it flipped over correctly. And so our most significant digit is here on the right. And then the least significant digit is here on the left. So it's backwards, basically, from how every other numbering system is going to use it in the documentation. And eventually, when I write an assembler for this, it's not going to use this notation either. So basically, it's just for this initial part. We have to use weird notation. But that's okay. That's okay. Alright, I'll go back to this. So, we got, so what we have to do, first thing first, we have to set up its mode, because it doesn't know what kind of screen it's controlling. So that will be the function set instruction. So we want to send 0, 0, 0, 0, 1. The L is the data length. trying to remember what that is. Number of display lines, I think, is a 1. Or is that 0? Why doesn't it say what these are on this page? It's on the page I didn't print. Of course it is. Of course. Let me go look it up. I don't care. Okay, the Hitachi HD 44780U. We'll just we'll find out what these mean real quick. Most of this data sheet I don't need, which is why I only printed off a few pages, but I did need to know what the other stuff is. Alright, here's the commands. What? What? Surely it tells me. Oh boy. Oh boy. It doesn't say. It does not say. Function set. So let's see what it says. Internal reset circuit automatically initialized. Following instructions are executed during initialization. Okay. Okay, so we want DL to be 1. We want N to be 1, I think. But I can't find where it talks about these. Yeah. And sets the number of display lines. Right. It does. Ah, here we go. Number of display lines. N is 1. We have 2. Which is why for a 4-line LCD, they stack them interleaved in a weird way. Because you can only have up to 2 lines with this particular driver. So, yeah, we just set that to 1. So right now it's on a 1 line, which you probably can't see it. But basically, there's just a, if I put it here, and then I increase the contrast, you can see it only has 1 line. So, that's that. Okay, so we want to send 0001. We figured out the DL we want to be 1, which puts us in 8-bit address, 8-bit command mode, which is what we have. We then want to be, we have 2 lines, so the next one's a 1. And the character font we are using is 0, 5x8. Yes, 5x8. And that should work. I guess we'll find out if it works in a minute. And then it has 2 more just don't care bits. And somehow I think I have put too many. Oh, yes. These 2 aren't there because those are the register select and the so this is send LCD command. What this does is it resets or sets the screen function, which to the proper one that is for our screen. And then we wish to turn the display on because it is currently off. So then we send. Okay, yes, send. The display command, LCD command 0 0 0 1, and then DCB. DCB. D is whether the screen's on or off, and then the cursor on or off. Want that, but we will turn the blinking cursor on. That should be 8. And the other one is more than that, so I need to figure out what I did wrong there. Or I need to figure out what I did wrong here. 1 2 3 4 1 1 2 3 4 1 1 0 1. What did I do up here? I think I did too many extras. 0 0 0 1. One 1 0 0 0. Okay, that looks right. And so this will turn on display. Okay. Now there are a few things we have to do, which is send is actually its own thingamadoodle. However, it almost does the exact same thing as sending a... Oh! Hello, Thunder! I say no one was watching, and then suddenly you're watching. Yes, it is a lot of jumpers. That's because this is a whole computer. Let me show you the whole thing. Anyways, I should be on this screen, because if I wasn't, that could have been a problem. Alright, back to this. So we should be ready at this point to print stuff. And hopefully my internet doesn't cut out again, but I'm sure it will, because that's what it does. But yeah, anyways, Thunder, if you have any questions, go ahead and ask. I'll do the best of my ability to answer. Otherwise, I'm just trying to get the Hello World program working on this, because I'm doing a challenge where I can only program it with these switches here. So with these switches and these buttons, I've made a little by-hand programmer. So, and then I'm going to work up to where it can program itself. Alright. I know many people have wonky internet, and we just have to live with it. Mine might be a little bit more wonky than most, but we'll make it work. We will make it work. I don't know why I keep looking over here because that's where chat is. And my webcam's over here. What you gonna do? Anyways, I'm getting distracted. Turn on the display. Yep. And next we can begin to print characters. Okay. So good to go. Okay. So then we want an instruction that can send commands or data. Would be nice. Okay, so let's do a write LCD, because that will be one more than print character. Well, if you enjoy just hanging out here, that's fine with me as well. To sort out the board, it took me like a week. It actually wasn't that long, surprisingly. Might have been 2 weeks, but yeah. I was kind of working off a design I had a long time ago, so it didn't take as long as it could have. Okay. Well, when we want to write to the LCD, we need to know a few things. What we need to know is what we want to write and its destination. There might be a better way to do this here, because writing to the LCD is like a one instruction thing, the way I have it hooked up. Instead, a wait instruction could be better. So what we need for that is to oh boy. Read the busy flag, which we will read LCD busy, and if it's busy, okay, or while it's busy, and that will just keep calling that. So then what we can do is, instead of calling send, because send is a bit more, we can do like write and then wait and then write and then wait. And I could put that into a function, but because of the way I'm doing things, that would be a little bit more difficult. Then for print character, we will make an instruction for this, and we will write LCD the character on the stack. Oh wait, no, we need to wait. Then we can write the character onto the stack, up from the stack onto here. Put a, or even better, just kind of write this out as a function that comes with a char. Okay. This should work. Now I need to write it out in assembly and then convert it to machine code. So let's do that. Okay, so for initialize LCD, now we're in assembly. Get rid of this document. We know how to initialize the LCD. Now I can bring up these documents, which have the assembly instructions on them. So, first, probably just... Can I write an immediate? Can I store immediate? I don't think I can. Where's the store instructions? Store A, store P, SEP. What does that do? Move P to P. What? No idea. Yeah, I'm just going to use 6502 instructions, not the 816 instructions. Can store Y and store Z. And store A and store P and store X. Okay, so I can only store the registers to a memory address. So if I want to move memory, then... Or, yeah, if I want to put an instruction in memory, I gotta do it. Okay, so we first have to load A with an immediate that way, and then I have to store that into, oh yeah, this one I forgot. So this one's not even on stack. This one's in register A, but we probably will need a stack to make everything work. So then we store A to address, and I have my memory map over here for helping me. So we need low bus, which is FD, and then 70. FD 70. Oops. All right. And that'll get her done. Okay, and so that's this part. Now technically, that's what I did wrong. Technically, we should wait first. So I should call. Or I can't jump. We need a stack. We need a stack. So where is the call routine? JSR. Jump to subroutine. And this will be a label, and I don't know exactly what that label is going to be yet. So, jump to subroutine. What was it called? Wait, LCD. Alright, then we can jump to subroutine, wait LCD again, and then we do a load A with store A into the same location, and that should be good. Well, yeah, so, I mean, I think you've seen that my channel is called Before the Basics, and I'm going way back on this one, where I'm going back into assembly, you know, directly messing with the bits of the computer. It's kind of, I designed it based on a retro computers of the past, but then I also took it and added like an Ethernet controller and SD card, so it's got modern stuff. It's even got a touch screen. You can't see it, but it's up here. There's a 320 by 240 touch screen. So, and technically, I think I figured out that it can run Linux. It'll take forever to get to where I can program it with Linux, but it can do it. It'll probably run very slowly, but it'll run and it'll do things. So eventually I might upgrade the hardware and do something different, but for now it's just a fun toy to mess with. All right. So that's initializing the STD. So at this point we can return. I think it's just return and not anything else special. Oh, it is special. Because they also have an instruction to return from an interrupt, and they have an instruction to return from a long subroutine, because you can jump across boundaries. And so you have to know if you need to jump across the boundary or not, and no. It's a complicated thing. because I've been using caps, I'll keep using caps. Maybe I should use lowercase instead. Anyways, wait LCD. Let's go ahead and make this instruction. So the first thing it's going to do is well, this one should do it too, depending. Do you need to do it? The question always is, who do you make store A? Do you make the caller or do you make the callee? And I guess we should probably make the caller. That is definitely not the instruction. It's probably PHA. Yep. And then later we can do a play. So this will push A onto the stack, and this will pull A off the stack. So, Thunder, how much do you know then? Do you know programming at least? Or are you just here to hang out? I'm curious. Okay. So we needed to read. So that means well, actually there might be a bit test we can do. Bit. And that has a note. Oh, that's the AND operation. That's a weird one. Usually people use that symbol for exclusive or. Okay. So it will A and M. So it'll take the accumulator and add it with M. So we want to test a specific bit. Oh, I forgot to write down the bit. Which is a 1? It's the first bit. Okay, it is. So we just want to test the first bit. That's too many zeros. Immediate. Engineering student doing majors in electronics and telecommunication. Final basic MOSFETs and BJTs. No idea about microcontrollers and microprocessors. Okay. So you've gotten through the physics, but not the digital logic parts. Which is all good. Maybe you'll learn something. I don't know. I'm trying to go over everything in more depth on my YouTube channel. I can't remember if I have that linked on Twitch. I really should. But I'm going to try to go over everything in depth there so that it can kind of be understood from the ground up, even if you didn't know all that much beforehand. But for now, that's not there. I'm working on it. In between the streaming, and then I'll be doing YouTube videos on other days. So, yep. All right. Branch bit. Right, we run bit. And I think I just need the Z flag. The other flags are established by some memory modes, but we don't care about them. So if we then do bit test, and we wish to test for that bit, and we want to do it with, I think, yep, I can do absolute memory location. Great. So, yeah, it's still the command register, I think. Is it the command register? Sure enough. Huh, that's the only thing you can read from the command register. Okay. then that's the one we'll use. And then we can return from the subroutine. However, before we do that, we have to push and pull A. I'm beginning to wonder if I should even use A as a area you can put stuff. But it won't hurt to push and pull. Which means now we need an actual program to run. Well, the first thing we have to do is we have to initialize our stack, because since we have one, we need to put it somewhere. Now, when we push the stack, which way does it go? Push, push. Stack goes down. So we need to start it high. Yeah, let me grab the link real quick. Because I must not have put it on Twitch, which was an oversight on my part, and I will need to do so. Just make sure that that is what we're looking for. Yep, that's the one. Oh, now I've done it. That doesn't have the... Oh, yeah, has this stuff been... Man, I was supposed to have music on, and I haven't. I don't even know if it's on right now. Oh, there it goes. Oh, when I lost connection, of course, it probably did the thing. Let me just throw this in real quick. Oh, yeah. This is just the YouTube audio library. So it's nothing special, but... Okay, let me get everything organized again here. Yep, that, and then the notepad. Perfect. Okay, from the main program, we wish to, let's just do the thing that I know I'm going to want to do, which is initialize the LCD. Okay, let's get that out of the way immediately. And then the other thing I need to do is initialize the stack, because that's something it doesn't do on reset. Excuse me? You're gonna just turn off like that? Do you know that I'm not on this window anymore or something? I don't know. If I can't get this to work with the music, then I guess whatever. I'll figure something else out. I might be able to put it in the streaming software or something. Who knows? Yeah, because there it stopped again. It just stops. I don't know. I don't know. That's not going to help. Yeah, I'm sure. The only thing I can do... Alright, sounds good. 3 a.m.'s kind of early, so... I can't believe this stuff is doing this. No, my word. YouTube, give me your audio library and do it the right way. I just want I'll have to look through this later. No music for this stream. Because I don't want to accidentally do something where I need to give credit and then I don't give credit and then we're like, oh. So, yeah, we'll have to figure that out later. Okay. Anyways, oh man, what was that all about? Initialize. Right, we were initializing the stack. So I think I can do. Forget if I start out in emulation mode or not. Transfer X to stack. Can I transfer A to stack? Store Y, store Z. Oh, those are the store instructions. Transfer A to Y, transfer C to S, transfer C to D. Technically, I could use transfer C to S. That would work. But at the same time, I think I keep doing that. I think I'm in emulation mode, which could cause problems. Let me look that up real quick, because that's gonna be a problem if that's true. So we have the W65C816. And I needed data sheet. Oh yeah, there's a pin. There's a pin I can check. What pin is that? E. Right above read write byte. So right here. We are in emulation mode then, is what that means. Over 6502, yep. So emulation mode, select flag is selected by that thing. So E equals 0 is when we're in native mode. So we do start out in emulation mode, which is fantastic. Okay, so now I know that it resets into emulation mode. Now I need to figure out about the stack in emulation mode. Wish I could put in 2 words, and if it found it within so many spaces, it would just take me there. Yeah, I know. How does the stack operate in emulation mode, though? It's gotta interact with it like the 6502. It has to. We are going to program it assuming it is exactly the same. And then we'll fix it if it's not. So, let's do that. Also, well, if we're dropping the stuff, what are you gonna do about it? 2 minutes ago. Okay. We're dropping lots of frames, which is a problem. Well, then do less. I mean, it's not like my computer's the problem. It's gonna be my internet, and dropping 50% of the frames isn't that good. It's not that good. Why are we dropping so many frames? I'll have to watch these back and see what went wrong. And see how bad it was. If it was really bad, I'll have to definitely fix it. If it wasn't too bad, we'll make it work. We'll make it work. If anyone's there and it's really bad, tell me. I'll restart the stream with some different settings and see if we can't get the frames to not drop so much. Because 50% is not good. That's like basically making it a 15 frame per second stream. So, anyways, let's actually do what I'm trying to do. That's the problem with this starting out streaming thing. It's like, oh, I've got to fix the stream and I've got to fix the other stuff. It's just really bad. I've got to fix. I don't have music. I've also got this thing running in the background, which is maybe causing me to drop frames. I don't know. Okay, anyways, we load A with the thing we want to make as our stack. We do A to X, and then we do X to S. And that should load the stack with FF, which will put it at the end of the stack, and we'll be good to go. And we can start using subroutines. And I have RAM mapped into that area, so we should be okay. Yeah, I guess I'll just single step instructions and see what it does. Because we'll know when it's pushing to the stack. Oh, there's the stack. That's what it thinks the stack is. Okay, so this all should work. We then initialize the LCD, which we'll put somewhere. We will then what will we do? We need to do. Oh yes, this thing. We'll just throw a letter on. Maybe the first letter of my name, which is a B. My name is actually an M, but the channel's name is a B. So let's put a B on there. B. Hex 42. load that in there. This is a hex 42, right? I read that correctly, right? Capital B, hex 42. So then we wish to print a character, which is 7-1. It should be. Okay, it is. So for print character, we wait LCD, and then we just store A into FD 1. So that should work. That should work. It should work really well. And then we return from subroutine. Wait, LCD. Oh, jump to subroutine. I thought there was something missing there. This almost doesn't need to be a function, but it's nice to have it so that you can tell what you're doing. Okay, and then we'll just loop forever. So jump to self. We'll use this for like self or something. I don't know. This is jump to self. So some of this stuff should be pretty easy to get up and running. Let's go ahead and let's program our thing. Oh, right. We got to turn this all into we got to turn this all into machine code. So let's start that. Do I put it all in hex first or not? Anyways, we're just going to do this function first, and then I'm going to single step it, and we'll see what happens. Yeah. So that means I need to convert this one first, which will just be down here. So this is now machine language. And this is program main, which we're going to put at not 00. I can't put it at 100 either. This can go at 200. That should be fine. So that's its memory address location, where we're going to actually put this. We want to do LDA immediate. So if we go to the... Did I just put that over here? I'm a brilliant man. Load A. It's on this first page. Immediate. I. What do you mean? Oh. Well, no, I know there's a load A immediate. Right? It has it in the thing. but there's I. Oh, I is not the addressing mode for immediate. That is indirect, probably. That would have been very wrong. A9 is what we're looking for. So we have A9. And then FF. A2X. Luckily, there's only one of those. Oh, you know what else I can do? What I can do instead of this is I can just, because I don't need it in A, I can do that. So now instead of 8.9, we're going to do load X, which is A2. Alright, so that's going to work out better. And then we do X to S. I can't happen to like load S, can I? I don't think I can. No, I cannot. I can store it, I cannot load it. Transfer X to S. Okay. All transfer instructions start with T. Let's make sure we keep that right. So that's 9A. Okay, jump subroutine is with absolute, I think. That just makes sense. Is 2-0 and then whatever we have for that one. So if we just want to make it easy, that's where we'll put it. Which it actually comes in this order: low first, high second. Okay, next up, the load A instruction. Load A immediate, which of course I haven't typed that in correctly. And that'll be the A9. Okay. A9. And it needs a thing, so that's gonna be 32. Just make sure no one's chatting with me. Okay. A942. And then what's next? Jump subroutine. So another 0. This one's going to be to print character. We'll just keep counting up. Except for this one actually can't be 3. This one needs to be 4. And this one needs to be 5. Because our wait instruction will be number 3. Let me go ahead and just put a label table up here for me to make it a little bit easier. So wait LCD equals 300, and this can be packed a lot more tightly because right now I'm using 256 bytes per function. We don't need to use 256 bytes per function, but because it's such a small program, I don't need to tightly pack it, and so this is easier to track. So wait, no. Print char 500. And then init LCD is 0400. And I'm writing this in RAM because I don't want to write it under ROM. It's just not a good idea. All right. Let's see. Let's go ahead Well, let me, yeah, we've got a lot of things to do over there. So, let's go ahead and move over at this point. Let's see, am I going to be able to convert this in my head to binary? Yeah, we should be fine. So, let's move over to the programmer screen here. Okay, okay. That seems good. And now, what we want to do, we got a few things to do here. We got to pause. I have not disabled the high bus. I was wondering about that. Disable the high bus. So that can't possibly happen. No creaky chair. Okay, and then we want to, let me actually, because this is not necessarily how that's going to work. There we go. And now we know that I've gone 1, 2, 3, 4, 5, 6. Or that, wait, this is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A, B. So this will be jump to B. We'll do that in a minute, because I'm not sure what the jump instruction is. Well, let's just find it. Jump absolute is 4C. Oh, and this is not 0B, this is 2B. Shouldn't work. So this should be the program main function assembled into machine code. So we should be able to put it in. Now, there's a few other things I have to do over here. But anyways, we're paused. I should be able to step instruction right now, and it should be great. Yep, we're stepping instructions. I could also turn off the clock, and I will do so because, well, yeah, I think I'll do so. We will manually clock this. Alright, so now we're on manual clock. Which means I can re-enable things if I wanted to, but it really doesn't matter. We're going to turn on the bus enable so that now I have control. I need to find my pencil so that I can flick these switches a little bit easier. Oh, what have I done with it? Aha! We found it. Alright, so flick the switches. What we want to do is, boy. Okay, first we got to get the address right. So, let me disable ROM for the moment. Oh, ROM's write protected already. Let me just disable it. Now my memory is disabled. Okay, but we gotta enable low bus. We gotta, okay, don't enable low bus yet. It's very confusing sometimes. I'll get used to this and it'll be a lot faster. So I've got to load my counter with 0. Now we can enable low bus. And what do we want to set that to? We need to go and write the reset vector to be something else. Where does it start at the reset? I need to write that down so that I have my reset vectors correct at all times. Actually, I might have grabbed the vector table. I think I did. I think I have it in my papers. In these papers that I put on the door. Okay. Here we go. Vector locations. For those who need to know. So, although I was thinking of just changing the jump instruction. Let's modify the jump instruction. Okay, so for that, we need to go to the top of ROM, which is here. That's our most significant bit. What? Oh, of course. Because... Okay, when you go back, I just wrote to the... Oh, my word. I just wrote to my counter. There we go. Okay. We need to write to the upper bits here. So that's this address on low bus. Now we disable low bus, so we aren't writing that anymore. And so now we're at the proper location. We can now re-enable ROM. That's a jump instruction, so we will... Okay, that's disabled, so we'll clock 1. Okay, so this is the first bit of the instruction, which is 0. That's the low address. We actually want this to still be 0. So go to the next one. And here, this is this part, which we want to change, because when we look at our program, let me just bring it up again, we can see that our program is going to start at, not there, here. So we need this to equal 2. So we will do that. That was the wrong button. Okay, so let's put in a 2 into here. And it's enabled, so we can write. Maybe? Oh, I have write protect on. Write protect will get you every time. There we go. Okay, turn the ROM write protect back on. That's just so I don't accidentally write to ROM at any point. And now it will jump to location 2 at the very start, 200, which should be fine. We'll find out. Anyways, those are a nice 2 sheets. Okay. So now, I've apparently had the YouTube chat down for a while, but no one said anything, so we're good. Okay. Let me go over this programmer real quick, because otherwise you're not going to know anything. Alright, right here. So this button, this controls the clock. I'm able to create clock pulses with this, which controls the main CPU clock. You have to press it for a write cycle to happen. So this is part of writing to anything on the board, except for one thing, and I'll get to that in a minute. This is the function step program. It allows you to step an entire function. So that's a really handy button, especially when debugging, and we'll get into that. And you can debug it at almost any clock speed, I think. I've tried it at 5 megahertz. It's hard to tell if it's working, but it seems to be working. With this kind of program, we can actually tell if it's working at 5 megahertz and know if we can go at 5 megahertz. Alright, this button, this is the write enable button. We push this, and it lets us write. Otherwise, we're always reading. So this makes it a write. And then this is the counter button, which controls these lower 8 bits of the address. If I press this, it counts up by 1. And then I have a switch up here where if I have that, it's load enabled. And so it'll load whatever's, we press right and this button, and it'll load whatever's on the switches. So that's how we can completely control this. Next up are these switches. So this is the free run mode or not. So basically, you can use this to pause your processor. If it's on, I accidentally set it up so that if it's on the left, I meant to set it up so that it was on the right. It would just require flipping some things. But at this point, I've learned how to use it this way, so that's how I'm going to use it. But yeah, basically, this turns on whether to pause on opcode. So, and that's what this LED shows, is when it's on an opcode. Over here, well, I'll go into the status LEDs in a second. This is the bus enable, so this tells the when it's on the right, the CPU will no longer have access to the bus. So that turns off the bus access from the CPU. This switch is load enable, I want to say. Yeah, it must be. Yeah, it is. And that one just automatically puts whatever's on the switches onto the bus. It disables every memory device. And basically it's used for forcing instructions or data into the CPU. And that's what you would use that for. I don't use it that often, and probably won't use it that often. But if I need to just suddenly jump somewhere, that's the one that I use. And then this last one, like I said, enables the lower 8-bit counter register to load whatever's here. And so I use that one a lot. Over here, we have the reset button. This resets the CPU and a couple registers and the screen up here. Down here we have the low bus enable pin. This allows me to write to low bus devices, and that'll just use this address here if I'm trying to write to low bus addresses. So that's kind of nice that I just have to worry about these LEDs, which is the counter register. Over here, I have some switches. We have the ROM and RAM enable, which is basically CPU bus enable, which lets me access these two chips. Down here, we have the write protect switch for the ROM. This allows me to protect the ROM from accidental writes from the CPU. It also lets me protect the ROM from accidental writes from me. And then over here, you can't really see it, but up here, it's just because of the way I'm zoomed in. It's not too important. You have switches for enabling the high bus and for enabling something else. I can't remember what that one enables and disables, but it does something. It must not be too important. I'll remember it later when I remember why I need it enabled or disabled. But yeah, there's also some status LEDs. So like I said, this one tells you when you're in an opcode. This one tells you whether you're reading or writing, and it's almost always on because of a read. But as you can see, if I press the right button, and the clock, because you got to remember that. Let's disable this real quick. Well, it's in write protect. You can see that it turns off because we're writing. It's just a little double check thing for me. This one lets me know if I'm accessing the register, which normally I am not, and I believe it turns off when I am, so it's normally on. And then this lets me know if I'm accessing ROM. This LED lets me know if I'm accessing RAM. And then there's two more LEDs over by those switches over there to let me know if I'm accessing high bus or low bus. Those don't work with the manual switches, though. Those only work from the processor. So there's the rundown. I guess I could put the low bus LED down here and attach it to the low bus. That way we would know. But, oh yeah, and then there is one more here. Currently this one's hooked up to when the LCD is accessed. Whew. There's the layout of the debug stuff that lets me know what's going on. So anyways, to start, out with here, we need to write a program. So let me see. So we don't need to be in ROM anymore. We need to be down in location 2. To get there, we're going to have to load 0 again here to that, and then we'll load 2. We got to enable this. And now we're in 2. Oh. Oh. We're stuck in ROM. Looks like I needed another switch. Okay. Because a lot of the CPU does stuff, I couldn't find a way to put all my switches to go through ROM. I mean, to go through the CPU's way of addressing everything. There's some address logic over here. So it didn't work. But now I can see that I have other problems. Let's see. So the CPU does that, does that. See, there's a register that controls whether you can because you can bank RAM into the area. So if I no, I see the problem here. I might have it correct already, but this is high. Why is that high? I can't remember where that was. Why is that high? Didn't I just write to say no? Okay, I don't know why that was high. And now RAM's on. Look. Sometimes there are little glitches, and we don't know why. Okay. So now we're good. We're in RAM. We're where we're supposed to be. I do have this hooked up to over here, like I should. And you know what? Bonkers. It's just bonkers. But it works. Anyways, I don't know why I just threw that. I'm going to need it again. Okay. We're in the start of the program now. Not a problem. No, we didn't have it enabled. I was going to say maybe something was writing a 1 there, and so it picked up on that. But I don't see anything that would have been writing a 1. It's a gremlin. Alright. The gremlins are here. So, we now have this location. We're in RAM. This is just some random data from RAM. It's nothing. What we need to do is we need to write this program. So A2. 2, and then we put our A in. We need to re-enable the RAM, possibly. Is it enabled? It is enabled. What am I saying? What? I don't know. So maybe the gremlin was the fact that ROM was enabled or something. Okay. And that would have been on accident. There we go. We've put the data in. A2. Alright, the next one. I guess that's true before I just go doing that. Because it's FF is the next one. So we step 1. And we write. Okay. That's FF. 9A is our next one. So, let's go ahead and step, and then let's write in 9A. So we need A. That's right, yeah. And, oh wait, no, 9. We need 9 up here. A. Hopefully I get this right every time because it's backwards. It makes it a little weird. As long as you're being careful and only thinking it, not seeing it, you're usually fine. So that's 9, and that's A. Yes. Yes. Okay, and so we do... That's a bit odd. Anyways, that should be 9A. 9A. It looks like it. And that's location 2. Yes. Oh. No, I didn't count that right. Oh, and true, I can check the location that I'm writing to when I'm writing that jump instruction. So we'll be fine. We'll know exactly where to go. Alright, so then we step to the next instruction. This one will be 2, 0. So the 2 is up top. The rest of that is 0. Alright. Looking good. And then 0 is the next one. Ooh. And then 4 is this one. Okay. A9 is next. So the lower part is 9. So there's A9. Go ahead and write that in. And then for 2, yeah, that's right. A and 9. Okay. We're good. Where am I? This is A9, right? Okay. So I should be here. This should be 4, 2. So 2 is the lower one. And this should be 4. That is 4, 2, I think. 0, 1, no. Sure. It seems right. Okay, and then we need 2, 2, 0. What's that? That was not 2, 0. Okay, I felt what was wrong there. 2, 0, and then we go to 0. 2, 0, and then 0, and then a 5, which is a 4 and a 1. And I don't think I write it there. I think I write it here. Okay, this next instruction says I should be at B. So let's check that real quick. This will be 8, 9, 10, 11. So we are at B, where I thought we would be. Which is good, because that means I didn't write something in the wrong spot. And even if I did, it's easily fixable because there's space. So there's the correct amount of space. So we do need to write in the last instruction here, though, which is a 4C. So 4. I probably could have left that up because C, I think, is that. Yeah, and this wasn't anything. We're going to hope. 4C. 0, 2. Oh, I did this one wrong. Should be 0B02. 0B, B is going to be B. And then a 02. And that should be the program. So, if we re-enable things here, go ahead and flip the bus enable back. We're in pause mode, which actually I'm okay with. We will flick our clock back on, and we will reset. Now we're in debug mode, so we can step instructions and see what's going on. So, that was the initialization sequence. That was all what was supposed to happen. However, oh yes, we are now in the jump instruction. So after this jump instruction, and that was the wrong button, we should be where we expect, which we are. So now we should be at the start of our program at A2, which it looks like we are because that's an A and that's a 2. So after this instruction, actually, I'd like to single clock this instruction. So what we do for this is we do this way, we press the step instruction button, and then we go ahead and give it a clock signal. And this will begin to work properly. So now we have FF, which is correct. Okay, that looks fine. Now we're going to be in another instruction, and that looks like that's what we are. Okay, this might have needed a clock cycle to do stuff, which it's looking like it is that way. Yes, it is, because we didn't adjust on that second clock cycle. So it needed a clock cycle to do something for the transfer, which is fine. Most instructions on the 6502 and the 65816 need 2 cycles to process an instruction. So sometimes there's a dummy cycle where it's not actually accessing the bus, and you have to account for that if you're going to do some other fancy tricks, which I did account for later on. Almost forgot to, but I did account for it. So now we're here. We have done nothing of value. Oh boy. Okay, right. Now we're at the jump subroutine instruction. So this is the first instruction that's kind of important. What does the jump subroutine instruction do? So we need to get the cycle sheet. The cycles sheet tells us exactly what everything should do on each and every cycle, which is helpful for when we're debugging. And we are using absolute mode for JSR. Okay, so the first thing it should do, so it'll just load the opcode. The next thing it should do is get the new PCL and new PCH. So these first few instructions should be just kind of what we expect. So it's grabbing the new PCL and the new PCH. That all seems fine. Okay. Then it is going to do nothing? That seems to be correct. Now it should write the PCH2 stack. So we should be able to find where the stack is at this point. And then possibly the PCL stack. That seems a little weird. We're going to find out. But one of these should be 2 stack. The other, and the other one, we might not have another one. So we clock. And it's going to write this to stack, which the stack is at a really weird location. I wouldn't have expected it to be here, but it is. As we can see, the high bus has a 1 on it, which is the weird bit. I wasn't thinking it would. Yes, I was. This is exactly where I thought it would be. Never mind. So FF is where we put it. This is where we said the stack should start. And in emulation mode, it's going to put this automatically in the bank of 100 through 1FF. And so this is the one that it automatically does in emulation mode. If we were in native mode, this would not be on. That's what I would have expected. And so this is exactly what I expect since we're in emulation mode. The 1 is here. It's perfect. This is exactly what we wanted. This is what I wanted to check. And then I assume we don't have a second one because we're in emulation mode. So we should just go ahead and grab the well, let's just see what happens. Okay, yes, we go ahead and we go to the next opcode. But we aren't grabbing the opcode yet. We're just going there. At least I think. Oh no, we're back to where we were. So this next one should be us jumping and grabbing the next opcode. Okay, we got a few weird things going on over here that I'm not sure about. This is flaky for some reason. I don't know why. So that means something's writing to this, which is really weird. Because nothing should be writing to it. We're in RAM, for Pete's sake. But anyways. Is this LED causing problems? No? Anyways, it just seems weird. I might have to track that down and see what's up. Especially if it doesn't think it's a 1, that's going to cause problems. But I mean, there's so many places it can go is the problem. I can't remember all those connections. Let me see if I can find it real quick. One of these things is not like the others. Wait a minute, no, because this is the only... Oh, yes. So if it output from up there, that would be a problem. Although it shouldn't be. Let me see if I can find it. It should be easy to find. Because it should be the only one that's enabled. Honestly, I didn't see a problem up there. But I do see a problem down here. What? I must be tracing that. Okay, so this one shouldn't be on. It's on for some reason. Do I have? No, I don't. I could have had low bus enabled, but I don't. Yeah, this thing says it's not outputting anything. We gotta trace this. Or let me just press the clock a few times. Okay, so this was definitely a hardware problem that I need to fix. Otherwise, we're gonna have major problems later. So this goes here. No, it doesn't go there. It goes here. Then it goes up and over here. Then it goes down and around to here. Okay, so that's the one that shouldn't be on. The one that should be on then is where? It goes to here, and it goes up, and it goes to here. Okay, and then it goes down and around to here. Okay, so these two, both of those are on for some reason. And this should be low. Okay. So, let me go ahead and check what's coming out of the processor. Okay, so it's coming out of the processor correctly. That is a good sign. What it means is that the buffer is buffering it wrong. Or that there's something else trying to get in on the buffer. So the one that is incorrect is this one. Let me go check these enables up here. Both high. So those shouldn't be getting in on this. All the enables are high, so none of those are going to be like doing anything too weird. The enable on this is also high, so that one's not going to be doing anything. The only other thing that could be doing something weird is this guy. He's not doing anything weird. So who's the weird one? Do I have a loose pin somewhere or something? No? Okay. So which one is it that shouldn't be the one? It's this one, right? I think this one shouldn't be. Ah. Okay. So I do have this wired up wrong at some point. But as we can see, now everything is correct. So there was our problem wire. I gotta go look at the RAM datasheet and get that plugged in proper. Oof. And now you can see why I have said, if you don't want to watch these, you don't have to. But it shows everything that goes into doing this. And you can decide if you really want to take it on or not. So we need the RAM datasheet, which is the 512K Alliance memory. I can't remember what it is. The ASC, this is 4006 or something? 4008. I just need the datasheet. All right. The data sheet. What did I plug this pin into? So it's that way, and this pin is I think that one. BCC AA right enable. Why in the world does that have a signal coming down it? It's not an output. Now, if it was write enable, I'd understand. One, two, three, four, five, six. No, one, two, three, four, five. Oh, good, I just ruined the data sheet. It's in theory 5 down, which according to this data sheet, 1, 2, 3, 4, 5. It's just an address. It is confirmed to have power coming out. So something may be wrong with one of my RAM chips up there. I don't know. But yeah, it definitely has power, and it should not. Oh, Atlanta. Let me give you. Well, so much for that. I was hoping. Okay. So. It's just that pin. And that pin only gets connected over there. Both of them, it's address pins. So. I guess let's try. I'm gonna try. And here, I can maybe move this back once I get this done. So let me move this way. You can kind of see what I'm doing. I'm gonna replace the chip and just see if that fixes the problem. Which chip is it though? That's the question. Well, I guess let's pop one of them out and see if the problem persists. Oh my word. I found the problem. Oh, it's neither of the chips. Let me just get this popped out of here. I guess I gotta take these out or something. I don't even necessarily have to pop it all the way out. I just gotta get in here. So, let me see if I can show you this. It's gonna be a little tricky. Yeah, it doesn't seem like I can. Very easily. Right here, yeah. Okay, you can't see it. Right here, there is a jumper. So those two addresses are hooked together. So no wondering when I lit up that specific pin, it suddenly did that. There we go. Pull that out. Should work like a charm now. Let's pop this chip back in. And now we shouldn't have any weird voltage coming out on this. And I don't. So that can go plug back into where it was. Which was not there. It must have been here. And now everything should be golden again. So, I'm ruining these sheets. Stepping on them and whatnot. Okay, don't do that. Okay, I'm going to try to move this back to where it was now. Let's see. We're in the LCD programmer? Okay. Oh, I should have gone to the board to show that. Anyways. We're back here. I think I had it about there. No, a little bit more. Because I was able to see both LEDs. Oh, and a little bit up. Because we were able to see the full LCD. Okay, that should get it back. Whoa, that was a weird problem to have. Clearly a problem from when I built it. We're still dropping frames like crazy, aren't we? I will just have to... I'll watch this back and make sure that I'm not, causing problems. And then I'll make it better next time. So hopefully the VOD's not too bad. Even if it is, I'm going to explain all this stuff again. So we'll just make sure we do it right next time. Okay. And nobody's been chatting, so it's all good. Okay. Schmokey. So yeah, now that we got that fixed, we're in no man's land because we haven't written the rest of the program yet. So everything seems to be working so far, which is grand. Oh, you know what? It should have. Strange. Maybe it did. Maybe that's what I missed. It did need to keep the programs low byte, and so it must have done that on one of those clock cycles. And I just didn't notice that was what it was doing. So let's go back into write mode. And in write mode, we don't care where that is. But it would be nice if the processor was paused, so we'll leave it in pause mode. And then bus enabled. So I think that's all I needed to do. And then we're here. Now we gotta jump to the proper location. Now, luckily, because we stopped right where the code was going to, we are exactly here, which is here. So we can write the code to initialize the LCD, which is grand. So to initialize the LCD, first we push A. $48. I say 48. It's 48. This is or you have 4. So what I'm gonna do before I get going too crazy. Well, actually, I'll put us back into workspace as well, but I'll erase this. So we'll turn on that load enable. We'll turn this off, and then we'll do that. And there we go. It's all good to program that space now. So let's do it. So now we got to come back to the workstation area. We got to hand assemble this. So hand assemble. These are the cycles. I don't need these. These are something I don't need. Of course, I put my instruction reference on the back of it. Okay, get rid of those for now. Don't need them. We'll get them later. So what we need to do is, push A. That's what I have done so far. I'm going to zoom out on this. You might not be able to see it as well, but it will allow me to write and read at the same time. Oh boy, I'd have to go really far out. I'm not going any farther out than this. So oh, you know what I should also get it to do? I should get it to clear screen. That's a pretty simple instruction. It's so simple, I think I actually remember it. So, we'll do it. Yeah, we'll do it up here. This is just in case if we reset the system and it wasn't a power on reset. So, this one just happens. That's the completely wrong way. There we go. That should reset the display. And yeah, we'll make that work. Okay, so the first thing we do is actually that. It also needs to do this. So there's going to be a lot of that too, which is kind of nice. LDA immediate A9. Okay, show you A9. And the thing we do on that A9 is that we can actually just do it this way, or we can read it out and put it in as X. It's 1. And then we wish to store a absolute mode. And that'll be 8D. This will be an address, and that address will be the low part first, and then the high part. Okay, and then we jump to subroutine. I wrote that slightly wrong, but now it's good. And jump to subroutine is 2.0. Oh, we're getting there now. We're almost writing in pure machine code. Then we need to do another LDA immediate. This one is 3. 3, 8. Then we put that one to the same spot. So hopefully I'm doing that right. That seems right. And then we're going to do this again. Okay, then we do this again. And this time it's 0. There's something weird going on here. I'll have to make sure that these are in the right order. Because it doesn't seem like they are, but... Because there's a 4-bit input mode, right? And how are you going to input the 4-bit switchover code if you have to do it from there? Maybe the 4-bit input mode happens on 5 through 2? Maybe? Because that would be a 4 with a 2 don't care bits. And that would allow you to set your data length. Anyways, we're using 8, so as long as the function's correct, and it looks like it is, we don't care. Right, I was looking at how the command works. So it's 0 and then 8, 9, 10, 11, B. I have not memorized B yet. We gotta work on that. So 0, B. And hopefully my mind's working and all that. Okay, that loads that in, and then we just do the thing again. What do we do? Wait a minute, I haven't even done print character correctly yet. Oh, yes, I have. Yes, I have. I haven't done the wait LCD correct yet because I test it and then I don't jump anywhere. I need to like branch if 0 back up to and that'll. So these I'm going to use as local labels. They aren't standard in many assembly languages, but we'll use them for now. Because I can make this whatever I want it to be. It's kind of just whatever because I'm hand assembling it. Okay. Oh, well, there's all the stuff on what equals what. Oh my goodness. I was looking all over the place for that. I got the data sheet up online, and it's right here on my piece of paper. Figures. Oh. Did I set that to 0? Because that would be bad if I did not set that to 0. I did. I set it to 0. So we're good. All right. We just need to get it to print a character, and then we can get it to say hello world at some point. Oh, yeah, and then all this code's going to go away when I power the thing off. Well, once I know it's working, I can either put it on the EEPROM, or I can create a new program to hold on to it. Which will probably be what I do next stream. I will make some utility functions that can transfer code. Transfer code from RAM to EEPROM. Transfer code, well, yeah, we'll just do that first. Then, I mean, I guess we can look at getting the SPI up and running, and then we can have code to transfer from SPI EEPROM to the board, and from the board to SPI EEPROM, which is what I want to do for most things early on. I don't want to put it on the main EEPROM because then I'll take stuff up and we'll fry our EEPROM. I have more EEPROMs. I have like 6 or something, but I would prefer not to fry the EEPROMs too quickly. Not that we likely will. If I write a good, efficient thing that writes only one block every time, it'll be good. And I will actually be the one writing to it more by hand. Because every time I write a byte, it rewrites the whole block. But I'm not planning to do 100,000 writes to the same block by myself. So we should be okay. It should be okay. I think it's a 64-byte blocks on that, so it should be okay. What was I doing? Oh, yes. This one translates to load A 0B, which is this one. So we need to now store it to the same spot we always do. And then we pull A. Oh, what I could do to test this, I don't need the full Wait LCD code to be working. I can just return at that address, and we can test the initialization code. Because if that works, then we can write some wait code. And then if that works, this should be branch if not 0. And then if that works, we've got it. And we can start trying to write characters. Actually, we can write characters before we do the wait code, because the wait code is only needed for when we're clocking really fast. Otherwise, it'll always be done before we ask it to do something else. So we need a PLA pull A 6.8. And then you do a return from subroutine, which is 6.0. Okay, let's go ahead and convert the other two just to make it work. The org the organization for this one is going to be 0. We just did 0400. Let's go ahead and do 0300. And this one, will have problems because that's the way we like it. This one's the wait instruction. So first thing it does is do push A, so like this one. And then it does LDA. It loads an immediate to A, which is A9. We already know that because we've done that before. It then does that as 80. It then does bit test, and on the absolute, something weird there on my paper, 2C. And then what? And then what? Oh. We need an address to AND it with, which was FD71. Oh no, 70. So same address we always use. We're doing a bit test. Then I need branch if not 0. Well, yeah, where's my branches? I have branch if 0 for sure. Oh, okay. It doesn't have 0 specifically. It's branch if equal and branch if not equal. Branch if not equal is branch if z equals 0. So that would be branch if not 0. Yes, because if they were equal, it would be 0. So branch if not equal would branch if it's not 0. And that is D0. So let me go ahead and go up here. Now in my assembler, I'm going to have branch if not 0 because that'll make it easier to read. Branch if not equal doesn't necessarily make it easier to read. I guess it's the same difference when you really think about it, but I will probably put branch if not 0 in there. Why did I say 6? Did I mean 2? That's supposed to be D0. Oh boy. I didn't mess up anywhere else. Okay, and it branches negative a lot. Oh, that's because I put it in the wrong spot. That is supposed to be 6-0. Let's not make that mistake again, yeah? Negative. Let's see here. So this is considered 1, -1, but you can't branch -1. That's an important thing. Branching -1 branches you to here? It's weird. It's weird. You go back -2 will branch you to here. Yes. I think so. Or does it branch you to here? Branch instructions are weird. They don't work the way you think they should work. And so you end up being in a bad spot. Oh, we don't want to constantly push, so I kind of need to get this right. I think branch instruction will end up here. Okay, if we branch -2, we'll end up like here. It's weird. So 3 and 4. So in theory, we want to branch a -4. Let me write down what 4 is real quick and I'll invert it. Oh, invert. 4 is 0. And so we invert that. And add 1. Okay. That should be -4. which that is F. 8, 9, 10A. We'll see if it works. If it doesn't, I'll have to do something about that. But if it does, hooray! Okay, so that's my branch instruction. And then pull A, which is 8. And then you do 6, 0. Let me just make sure that that's right. Okay, never hurts. Return from subroutine. So to subroutine. RTS 60. Okay, yes, yes, it is right. Very good. So this is our wait LCD. This is the initialize. I should probably go ahead and test this right now because it's going to be easier to test at this moment. And then at 0500, this is the print char. All that happens on this is we jump to subroutine, wait LCD, and then we store A in FD71. So store A absolute is, oh yeah, I should be using it a lot. It should be AD. And this, in theory, then 60 to return from subroutine, should be able to print the character if we get all this code written in, which I might as well write it all. Because the initialize is actually the longest one to write, and that's the one that I have to get working. The user is just 3 lines. So let's check where we are. We're at 4, 40. So that'll be this one, which is the initialization code. Good. So then we need to start writing stuff. We didn't have to do anything there, so we're all good. We can enable our RAM. And let's start writing. So first is a 4, 8. Four 8s. Next is a 9. A 9. And then 1. Okay, next up is 8D. 8. And then D. Oh, did I do that right? I'm currently on 3. 0, 2. And I'm on 3? Oh, yeah. 3 for 8D. Okay, I did it right. Okay, okay, we're good. Okay, and then 7 0, which, let's see, 7. There's 7, and there's 0. 7 0, and then 7D. Hopefully that's all still correct. Okay, now we're here. 2 0. Oh, that wasn't the right button. 2 0. And then 0. Oh, I should have this on program remote. But you can kind of see what I'm doing now. 2 0. And then 0. And then 3. And then I'll switch over here and show you stuff. Okay, here. And let me make it so we can see the programmer a bit better. Pew! Perfect. Now we can see what's going on. I could always see what's going on. You can see what's going on. Oh, honey, where am I? I'm now in A9. So, this one needs to go down. This one needs to come up. And we need A. A9. Next. We can run back through this to make sure. 3 8. Oh, don't do that. 3 8. And then 8D. So that's 8. We need D. And 7 0. Seven 0. And then 7D. 7. That's wrong. Okay, we should be here now. Hopefully I'm doing this right. 2 0. Zero zero. And then 3. Okay. I haven't gone forward yet. All right. We're here. A9. A9 again. Gotta love A9. And then 0. B. Have I been doing this stuff right? I have no idea yet. I think it's right. It's gotta be right. Back. Okay. Oh, I wonder what it say. A whole bunch of nothing. Okay, apparently that's just not working. Oh my word. If you're on Twitch chat, I can't read chat right now, so... Am I back? I seem to be. Yep, I'm back. All right. We're doing good. There seems to be just some people lurking, but you know what? That's okay. Let's see. So we got all this. I just did that, and for now I should be over here on 8D. Okay, so let's put that in. That was a B. A D looks like this. And that should be my 8D. Okay, and then 70. To do 7, it's these 3. Did I press the button? I didn't. 70 and then 7D. Did I press the button? We're near the end, so I can check over all this stuff, but I don't think I did press the button, which is worrying. Let's make sure we press the button this time. 6, 8. And 6, 0. Okay. Let's go ahead and just go over the program. Make sure that I wrote everything in right. To do that, we need to disable this. Just to make sure I don't accidentally do the wrong button press here. Alright, we can re-enable the RAM now. Now we're here. So, this should be 4.8. It is. This should be, well, let's not say what it should be. Let's look at what it is. It is a 9. Correct. 1, which is correct. 8. D, which is correct. 70, yep, that's correct. 7D, correct. Let me see. 2, 0, yep. And then 0, okay. 3, A9, okay. 3, 8, 0B. What? Where am I? 3, 8. I lost track of where I was. Let me put that here. That way I'll just know. 3 on top, 8 on the bottom. Okay, that's correct. Next up should be 8D. Yep. Then we have 70. That looks right. And then 7D. Okay. 2, 0. Looks good. And then it should be 0. And then it should be 3. Good. Okay, A9. Yeah. 0B. Yep. 8D. Looks good. And then, oh, yep, see, I knew it. I didn't press the button at the end, and that was going to get me. So we're all the way good until where I thought I maybe messed up, and I did mess up. So this is supposed to be 7-0. This is supposed to be 7D. Oh, I hope I didn't press that twice. This is supposed to be 6-8. Yeah. That's not right. 6, 8. And then this is supposed to be 6-0. All right. And that is that program. So then we go into random whatever after that. So that is now this programmed, which is good. Let me go ahead and zoom in on a bit of this. Let's go ahead and let's go off and write this one real quick, just because it's super easy. Turn off my RAM so that I don't accidentally write to it. Okay. So where we want to go is we want to, well, first, since it's easy, let's go ahead and clear my counter. Okay. And that technically shouldn't affect anything at all, so I could do that without disabling stuff. Then we're going to want to enable the low bus, and we're going to want to go to 5. And once we're at 5, we do the thing. Okay, we are now at 5. Oh yeah, let me go back here. So, okay, no, we are not at 5. I don't know what the problem was there. If I just released it wrong or something, but it keeps having that glitch, and I don't like it. Luckily, the CPU doesn't rely on that thing too much, but anyways, it's working now. We got it. Look, it's at 5. Okay. And so now we can disable the thing, and we're good to go. So we want to do 200003. Okay, this is easy. Like I said, easy peasy. 20, which is a yes. 20. We don't have RAM enabled. That's not going to help much. 20. And then zeros. Next one. And then 3. Yes. Okay. And then 8 and 6, 0. Okay, let's go through that one because I feel like I might have done something wrong. Woo! Okay. We need to go through the program. So, we just do this, this, this. That should have done it. Wait, but what did it do? Oh, it didn't do anything properly. Oh, it's because I'm reading off of... okay. We can still do this. What? Okay, that seems more correct. Alright, so let's go through this. 4.8 is what we're on. In theory, is that 4.8? That is 4.8. So let's push the button. Should be A9. It is. Should be 8.0. It is. Should be 2C. It is. Should be 7.0. Looks good. Should be FD. Yup. Should be D0. Okay. Should be FA. Alright. So I think what happened here is that I did something wrong. Alright, there's FA. Should be 6.8. Yeah, so I just didn't do that for some reason. So 6.8. That's 6 and that's 8. So let me do that. And then it'll be 6, 0. Alright, that should do it. So now we should be able to turn off the bus. Make sure everything's enabled the way it's supposed to be. It looks like it. Then begin single stepping the clock. Now something I am going to do is I'm going to go ahead and run the clock. And then we'll just step through the instructions. So instead of doing it the normal way, we're going to look at it up here in something a little bit more readable. Okay, so let's step instruction. Get through the reset. And then get into our actual program. Okay. So now we're on the actual program. We're in main. This should be load X. And we're just going to trust that it is. It seemed to be. And then this is going to be transfer X to S. Then this is going to be jump to subroutine, initialize LCD. So this should go somewhere else, which it did. Now we should be in initialize LCD. So this first instruction should push the accumulator. So step instruction. In theory, that did a push accumulator, I think. Oh, no, it did a lot more than that. Because now we're in a different instruction. We're in 3.0, which is wait LCD. So now it's supposed to do a push, but I doubt it's going to. Next up, it's supposed to do a load A. Okay, that's what that instruction is. And then it's supposed to do a bit test. And then it's supposed to branch if not equal. And that should be, is it 4? And honestly, it should be at 1. Why is it at 4? I gave it a gigantic negative number already. Let's see, if we do it from here instead. 1, 2, 3, 4. 1, 2, 3, 4. Press 4. If we did it from the branch instruction. Which might be how it does it. Because we go 1 to here, 2, 3, 4, but that would be at 3. But if we counted this as 1, so it was here, 1, 2, 3, 4, that would put me at 4. This would be 5 and 6. So I need to go back 6. The negative of 6 is okay, then you add 1. 1 plus 1 is 0. Carry 1. So that becomes F. One, 0, 1. A? Isn't that what I came up with before? So then do I need to go more than 6 back? I'm already going 6? What? Okay, if I start here, 1, 2, 3, 4, 5, 6. What? Something has clearly gone wrong. And it went wrong quite a while ago. So let's just reset. And let's step instruction. So now we're in the code. This first instruction is supposed to be 4.8. It is at a 9. Okay, we already went through 4.8, so that's fine. We'll say it's supposed to be a 9. It's actually supposed to be a2. And it's supposed to be FF. Where am I? I'm not where I think I am. Oh, it's because I haven't started it. Okay. Reset. This is the jump instruction in theory. Why are we reading that? Oh, it's my first thing. Um, what happened? Okay, I see what happened. It's still wrong. That first instruction is supposed to be 4.8. Oh, no, it's not. It's not. It's supposed to be A2. Then it's supposed to be FF, and then it's supposed to be 9A. This is telling me that instruction 1 is a 9. And it's not. No. Did I write for that? Oh. Oh. Somehow I think I wrote over it. Sorry about that. Okay, because this is a 1. Which, if we were doing that instruction, might make some sense. And then 8D, yeah. And then 7, no. What is this? Where did I go? Okay. Let's just do single steps and see what happens here. Because I am curious. Can I just do it? No, I cannot. Okay, yep, we end up here. Oh yeah, we gotta release it. Okay. So part of my problem is that wait, no, we're okay. Kind of. It's not working the way it's supposed to. That's for sure. Okay, so here we go. This is it loading in that. This is a jump instruction. Okay, we have jumped. Now, for some reason, it's all ones. At the location that it's supposed to be. A2. Okay, that's weird anyways. So this is supposed to be A2. So we step. No, we step. Instead, the next instruction I get is A9. Or is it 9A? It's definitely A9. And the next thing would be 100. Now we're already doing the wrong opcode, so it's gonna do something weird here in a second. So I don't know what to say. I guess I'll rewrite this main code and see if that just fixes it. Otherwise, I don't know. I don't know. So we have to get this back into workable order. There we go. It's in working order now. And I think I need to do something with low bus. So let me go do that. Low bus needs to be set to 2. Something weird about these 3 lines, and I'm not sure what it is. It's just something weird about it. Anyways, we have that working, and we have the other stuff working. So now we're ready. I need to redisable this and enable that. Okay, now everything's ready for us to program this bad boy. So A2, A2. And then F, here. And then 9A. Whoa, 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 whoa. Whoa, whoa, whoa. Oh, I know what this is. No, I don't. Yes, I do. Oh, I can't believe I keep doing this. Okay, back to here. Turn that off. Good sake. Why is it all ones? I put it all zeros, didn't I? What is going on? Why is this right? Oh, mamma mia. I'm about to lose my mind. Okay, I need you to go into 2. Okay, but don't write my RAM and ROM. Got it? No, you don't got it. Now you got it. Now it should still be A2. And look at that. It is. Okay. And then it's FF. Alright, nothing weird has happened yet. Now it's 9A. Oh, that one need to be up. Then it's 2-0. It's the completely wrong way to go. 2-0. Zero, 1, 2. We should be on 3. And then it's 0, 0. And then it's 0, 4. Oh, I don't remember. 5. Man, I really need to get in the habit of pressing the thing. Okay, A9. That's not A. That is A. A9. Okay. 4-2. Press the button. 4-2. Two, 0. Then 0, 0. Yeah, there was some other program written here which worries me. 0, 5. Did I press the button? I think I pressed the button. And then 4C. For C 0B because you got, what do you got? You got A, B. And then 0, 2. Now, I have no idea if I put that in right. So let's go ahead. Let's load enable, do the button. Hopefully this doesn't mess up absolutely everything like it has been. Oh, man. And now we can read the code. So this should be A2. It is. FF 9A. 2 0 0 4 A 9 4 2 2 0. This is supposed to be 0. And then this is supposed to be 5. And then we can do the 4C. It's this one. Then it's 4C. Then it's 0B. B, 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 A is this, so B is this. And then it's 0, 2. Okay. Now we get to go and find out that it's not jumping to the right spot because we somehow rewrote all the code over everything else. Wonderful. Hey! Okay. It's going to do its reset. There's its reset. Now it's going to do a jump. There's its jump. Now it should be executing my code for this, which is A2. Okay, yep, we're good there. Just go ahead and keep going. Looks good. A 9A. Yep. 9A. Then it goes 2, 0. What just happened here? Oh, right. So then it's 2, 0. And then into 0, 0, 0, 5. So it pushes to the stack. For now, 0, 0, 0, 5. That is supposed to be 2, 0 to start. Yeah, it's supposed to be 2, 0 to start. That's what we're saying. It's also supposed to be 5 and not 4. But you know, it is actually supposed to be 4 because I'm reading it wrong. So we're good. So it's a 4. 4 is here. It should be 4, 8. That is not 4, 8. Okay, so I think what happened here is I wrote this program. It's supposed to be here. I think I wrote this over the main program. And so that's why everything ended up weird. So that means I have to rewrite this, which is by far the longest subroutine. It's the LCD initialize subroutine. So, yeah. We're going to have to redo the whole thing. So let's get the programmer out and let's do it. Put on that bus enable. Disable this. Okay, let's try to get this done in a reasonable manner. But first off, you gotta load the thingy, my bubber, and you gotta Load it with a 0. Okay. Now what you do is you tell it to not load the thingamabobber anymore, and you put on the bus a 4. And we put that down here. I haven't enabled it yet. That's the problem. And there's noise from somewhere. I don't know where. It's probably these pins, if I had to guess, and I need them. But it's so annoying. The other thing I could do, which might make it slightly better, is instead of using the clock, I use the other thing. Because the clock line... Or did I accidentally remove the clock line, and that's why it's so off? No, there's the clock line. Right here. It comes down, it goes through here, it goes up here, and does this thing. I don't know. I really don't know. But anyways, it's there now. It's there now. Even though it's stupid, it's there now. Okay, I disabled it in theory. I don't know if it's actually going to hold true. Now, we need to write this program. And it's a long one. So let's try not to mess up. 4-8. 4. 4. And then 8. I think I need to write this into ROM, honestly. So we probably won't get to Hello World today. We'll just get to writing a character on the screen at least. And then I'll have the code for it. And I'll know it works as long as you write it correctly. And then we can get to Hello World a different day. Okay, so let's start it out proper. 4-8. Well, bam. Okay, next. A9. Well, that one's correct. Don't tell me I put someone else's code here. This is 4, right? Yeah. What? Okay. So we got A9 next. That's fine. This is not fine. This is supposed to be a 1. What did I do? Did I write someone else's stuff here? This is supposed to be 8D. That is definitely not 8D. 8D. It was, however, 0D, which is odd. Okay. Then we need 7-0. And then 7D. And 2-0. and then 0, and then 3. Well, that didn't quite look right. And then A9. A. Nine. And then 3, 8. Then 8B. And 7, 0. And I think it's 7D. And then it's 2, 0. And then it's 0. And then it's 3. And then it's A9. And then it's 0. B. That's not B. That's B. And then you have 8. D. Then 7, 0. And then 7D. And then 6, 8. And then 6, 0. And in theory, that is the program we should be running. So hopefully there's the other programs in the right spots, because if not, then I gotta rewrite those too. Okay, do the initialization to here. We're gonna jump. We jumped. That looks correct. So we're gonna continue. Yep, that looks good. Okay. Okay, now we should be elsewhere. Not yet. This is stack. This is still more stack. Now we should be elsewhere. And this should be 4, 8. Okay, it is 4, 8. The first thing we do is push the accumulator, which is what this will do. Yep, so that was a stack operation. Okay. And then the next thing we do is A9. So that looks right. 1. I can't remember what that does for me, but it does something. Oh, it loads 1. Okay. And then this should be the point where we try to access the LCD. So hopefully something good happens here. If it doesn't, oh boy. That is not the LCD. Am I accessing something though? Or, well, actually I can't say that yet. It's writing to whatever it's accessing, but it's not the LCD, I don't think. Well, that's not so great. Can I figure out what it is accessing? If anything. What? Well, it's gotta be accessing something up there, right? Well, sure, if low bus worked. Why doesn't low bus work? Oh no. This is showing that low bus is high for some reason. If I trace it, which means that essentially that's high. But why? We must find out why. No, output enable is low. This one's not a 1. Whatever that one is, it's not a 1. Okay. This has brought us to something useful for me. The thing is, that's behind the action point. So that means that that's what we actually read in. And nothing to do with anything else. So that should be this one. Yep, it's still low. And so clearly its output would be low. So the highest bit wasn't working. Oh, joy! I'm gonna go ahead and turn off pausing. That way I can just step through. And then I want to go until I'm in here. So that's just going to push. And then this instruction should be the one with the thing. So let's go ahead and let's look at what it puts. Oh, that's right. That just stores it. That stores it. Okay, and now we're going to put it somewhere. That loads it, and then this is going to store it. So first of all, make sure the instruction is correct. It's 8D. That looks right. So then this is supposed to be 7. 7? D. What? It always has to be FD. Is that what I'm doing wrong? Everywhere I put a 7, I have to put an F? That's what I'm thinking it is. Yeah. Yeah, that's what it is. So let me go through all of this. And everywhere there's a 7, we'll put an F. I also need to go into the other one, but we'll worry about that in a second. Worry about that in a second. Okay. Go ahead, put all this stuff on. Get that to pause again. Right to my register here. Okay, low bus is already set up. We should be good. Hopefully I didn't just write a bunch of stuff to RAM. Because RAM doesn't rely on the clock. Oh, I might have just overwritten a ton of junk. Oh, I need to deactivate RAM and ROM when I do that, because if you press the right button, it will write. No. Write is clock gated. I forgot about that. Write enable is gated by the clock, so it did nothing. At least it shouldn't have. It might have still. Okay. So 4.8 is fine. And then we have the next one, and the next one, and the next one, and the next one. This is wrong. This, I mean, everything can be copied about this, except for the top bit also has to be up. This is where I went wrong, because this is where low bus is not at 7D. I don't know why. I have it everywhere. This is... Well, I'm going to change it as I do it, so that I know where I still have the problem. Okay. Then we go to the next one. Okay, yeah, I can see that. Okay, and then we end up here. Do that and that. Yeah. A9? Oh no, this is 3.8. Okay, I can see that. 8D. 7.0. 7D, but you're not supposed to have that. You're supposed to have this. Okay. We fix this one. And now a 9. No, it's 2.0. and then 00, and then 03, okay. And A9, yep. 0B, yep. 8D, 70, and this should be the last spot to fix it for this function. And then we should have 6, okay. So that was for that function. Now, in order to make this thing actually initialize completely, we have to go check out 300, I think. Yeah. So let's go there. So first of all, disable you just so we don't forget. And then go to 0. Now, honestly, just load this in. Okay, and we gotta go to 3. I don't know why this wrote again. It did it again. I pressed this button and it loads. And it's not supposed to do that. It is not. Because this is not a clock button. This is a button all by itself. It does nothing else. Or does it do something else? It should do nothing else. But run up here, get inverted, but then I see that it goes over here. What's it doing? All it should be doing... Oh, okay, that's the counter load. So yeah, that's all it does. I don't understand why it messes with this. It's nonsensical. Anyways, we're at 3, 0. We can re-enable RAM now. Let's see what we have. Hopefully is what I expect. It's not what I expect. At 3, 0. I do not expect a 8, 0. Which maybe none of these start with 8, 0. Okay, so this was the rogue program that I wrote over something else. Which means I probably also wrote over something else with that one. But that is 3. Yes, that is 3. Okay, so we gotta rewrite the whole thing. 4, 8. A9. Wait, this might already be good. Because some of them use the same thing. A9. Okay, that one's fine. 8, 0. Well, it's good so far. 2C. 2C. Okay. 7, 0. Wow, what? It even has the FD proper. Oh. And I had it written down correctly, too. D0? FA? 6, 8? And 6, 0. I guess it was mostly correct, except for maybe that first value. Let me go back and check that thing out. And watch this, because if it goes somewhere, we're in trouble. You know what? I didn't enable it. What is it doing? Okay. Right now that should just be 4, 8. Okay. I guess that one's fine. So that means we should just be able to re-enable the CPU, reset it, and now when we get back to that 1 point, it should be good. So I'm just going to keep going until I see the address that I'm looking for. Okay. So here it is. It pushes first. Does a push. That was the push. Now it does a load. And it loads direct. Now it does a store instruction. And this time, when we store it, we should get this lighting up and that happening. No, we didn't. So where are we doing it? If anywhere. What do you mean? What? Okay, I just killed something there. Okay. I can think of a few reasons to do this, and most of them are hardware. So, I had a thing hooked up here that was supposed to do stuff for me. This one's fine. It's this one. But that's just my clock. One of these is a chip enable. And what it does is very special. Well, that one goes up to address, which it's supposed to. Oh. Okay, that one goes down to that enable. Yeah, that's what it's supposed to do. It should have 3 address pins, 3 enable pins. Well, let's reset and try again and see if I can figure out what I'm doing. Alright, we gotta get back there again. Okay, here we are. You push, then you load, then you do it. Okay. So right now, everything is how we would expect it. Well, true. Let me not do that. Let me just look at the address pins. Okay, the addresses are as I would expect. Fully as I would expect. I mean, we've got this lit up, and this is displaying the correct thing for the enable over here. It's writing the 1. 2 in theory, the LCD, but my enable's not happening. Where does this one go to? You know it goes down. wait a minute. This is high bus. This is not low bus. That's a high bus enable. So I put the high bus on 0. Oh my word. Good job, me. You were supposed to put that on 1. Hopefully. If I change it again, it will work. So, well, basically what we're saying is that this is supposed to be E. Whoops, I didn't mean to do that. So we need to go back into the addresses and see if it works. I might have to grab some food here soon, so just to let you know. We gotta go back to the future. Now I think I'm already there, luckily. Yes, I am, or I'm somewhere. I'm at 3, which is another one we need to fix. So let's go ahead and go fix that. 1, 2, 3, 4. So it should be here. Basically what we're saying is, yep, okay, you're mostly correct, but I need you to flip those bits. And now, that should be the fix. So now we need to go, and this is going to be a little more complicated. So let's go ahead, load. What is going on here? I must be fighting something during this, right? So I'm not going to keep fighting it because that's shorting things out for a little bit too long. So what we're going to do is we got to go here, but first let's get this adjusted. Or we can do this because I'm already going to have to do that. I don't know why I was trying to not. Okay, there we go. Now it works. So what we need to do is we need to adjust this to... Where's that spot I'm going to? I don't really care about the character yet. 4. 4 0. 0 0 4 0 0 4. Still got those weird stray stuff on there. I don't know where it comes from. And there we go. So now we re-enable the RAM. We're here. So then we go 4.8 A9. That's not A9. Oh, I see what I did. We'll see if I can get it back. Okay, I can. Don't load. 4.8 A9 01 8D70. Okay, and then go. And up. There we go. So that's the first fix. Then we go 1, 2, 3. 1, 2. 1, 2, 3. And we're there. Okay, and then we're here. So we go 1, 2, 3. 1, 2. 1, 2, 3. And this is the spot that needs to be fixed. Okay. And then we should have a 6.8, 6.0. Okay! Now we're getting somewhere. So, just reset the processor. Get this stuff back. Make sure everything's disabled that should be okay. And we check it out. So it's going to reset here. Here's its reset. Its jump. Now we're down in my code. And so now it should do something. We're expecting it to do something. So now I do the normal thing where I watch for it to get to that particular address. There it jumped. It's doing a push. It's loading. And now it's going to write. No. No, 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 no. Why? How? How has this put out a high signal? How? What? Of course. I am such an idiot. I did put it on 0. I've still got it wrong, even after all of this. This is FC. Okay, we need to go back, do that all again, and put it on FC. And then I need to change it in here so that I don't get confused again. It's because there's 512 bytes at the end. That's ROM and RAM. And then the 512 bytes before that is low bus and high bus. Boy, it helps when you have your notes all in order. All right, so same song and dance. Pause the CPU and let's go do it. Okay, so I'm in 4.0 right now, which is fine. This we're gonna do here. However, I have to reset this. Probably the easiest way to do that is to turn off RAM, do the reset, turn RAM back on. Oh no. Turn RAM off. Do the reset. Turn load off. Turn RAM back on. Okay. And then step 1. Look at what it did. Would you look at this? So now I have to put that back. I don't get it. Is it like a pull-up resistor or something somewhere? Or I need a pull-up resistor? I don't understand. Okay. Okay, I think we good now. Yeah, okay. Oh, I just wrote to RAM. What was supposed to be here? 4.8. That means I wrote over. Oh my word. Yeah, I did the mistake. I might have just killed the entire program. I guess we'll find out. Okay, this still looks good, which I'm glad. A9. This is no good. Alright, because this is supposed to be 1. Yeah, it's beginning to look like I really messed up some stuff. Now that's 1. That can't be right. This is supposed to be 8. D. I think. That's supposed to be 70. What am I looking at then? Am I not looking at the right code? 4889 8D 70FC. This is up in 40. Let me try resetting this thing again. But it worked. So this is now a baby. So this is supposed to be 48. How are we doing on that? Okay, that one's correct. And this one's supposed to be 2 something? 2 something. It's supposed to be A9. Which it was close. But it's just not quite there. Maybe that's because I'm not quite here. Or 8. A9. 1. 8D. 70. Yeah, I think I killed it. Good job, mate. There you go, 70. FC. I keep looking over here to make sure I'm writing this into the right spot, and it's always 40, so... So now it needs to be 2... 0. Or maybe it's already there. Because some of these won't have been rewritten. Okay, that one's good. 0, 0. This one was 0, 3. A9. Yeah, it's close. But it did get overwritten with some gobbledygook. So we need to make sure that we have it right. A9. 3.8. 3.8. Okay, that one's good. 8D. Well, the D's still there. Or is it? Oh no, it's not. 8D. Then it's supposed to be 70, which, some of the bits still there. Most of the bits are not, though. And then FC, which we're going to have to make a repair even if it does exist the way it's supposed to. Then it goes 2-0. Okay, that one's still good. 0. Okay. 3. Wow. All of that was correct. A9. Hopefully we didn't mess up any other sectors with that. But I think we might be okay. I have A0. So it must have only messed up some. A9, 0B. 0. And this got messed up. That is not it. AB 8D. It's close. It's close, but no, not quite. 8. And then D. C. And then D. 8D 70. Okay. I can see we still really messed you up. FC. That one's just miles away. And then 6-8. 6-8. Surprisingly, that one's okay. And then 6. Okay. Ooh. Hopefully that didn't mess up the other stuff. I guess we're gonna go find out because I gotta go check this one. 3-0. So let's disable the RAM first, as always. I guess it could have really ruined anything though. Okay. Let's just go ahead and set this to 0 for now. Nah. Okay. What did I just write to that is able to keep memory? Something seems to be always active then. Because if I do this, do I write to something? I do. What is it? Oh, it's some device in low bus. I guess that makes sense. If I do this, I shouldn't be able to write to anything, yes? No, something's still active. But everything's disabled. What? What is putting its bits on the bus and also writing all the time? We're gonna have to figure that out eventually, because that's no good. And that's what's been messing up my stuff. Some random chip enable is messing up my stuff. Is that a chip enabled though? No, that's just the address. I don't know. I don't know what it is, but something is out there grabbing stuff. So what right now is enabled? Because as near as I can tell, nothing is enabled. Woohoo! I mean, right, that one has a ground enable, which is why it's done that way. This one, I think I hooked up to its positive enable. You know what I mean? No, it's not enabled. Oh, well, what is enabled and on the bus? It couldn't be these things, right? No, because that's not data. Let me ask that again. It couldn't be these things, right? No. No, there's nothing. That came up without even doing anything. It's not. It's not actually display, is it? No. It's not the display. And it can't be the processor, because, yeah, the processor has something completely different on its mind. It's nothing over here. It's not something from here, right? No. No. It's not that. I highly doubt it's this at all. I can't even really pull it. I mean, it's not this. Yeah, no. Okay, but it doesn't even necessarily have to be. Well, no, it does have to be active right now. There's something that's active right now that can store data. I don't know what it is. Is it this thing? That shouldn't be able to like store data though. That would be just weird. I don't know. I really just don't know. It deactivates though and stuff. So let me just check. Is it you? Yeah, it is. Okay. I wasn't expecting you to hold values on you, but I guess it does. Well, then what's your output enable status? Because, oh yeah, I have you on always output. Wow. Wondering if that should be true. Or do I not? Maybe I don't. Maybe I'm going crazy. Oh no, it's gotta be on clock. Okay. So, interesting. Interesting. Perhaps I didn't account for that register. In which case, it will have problems. It will. Okay, but that's what's kind of there. It's being weird. Suddenly it makes a bit more sense. Anyways, I don't know how to make that one work. I needed to gate it somehow, and I'm not able to gate it that way, so it'll be rough. Okay. So now that I've got that where I need it, let's go back to what I was doing. And hopefully things don't break on me. Right. So this does its thing. This needs to be a specific value. It is that specific value because I need to go to re. Now that I'm in 3, we see that it has been destroyed too. Oh, joyous day. Glukle, I gotta put it all in again. Yeah, that glitch really messes me up. Just did it again. Oh my word. I might just have to give up for today. I'm not thinking. The programs are really bad. Oh. Okay, well, what we can do is turn this off. I gotta check things again. If I ruin the one program, that's it. I'm done for the day. If I didn't ruin it and it's still there, we'll keep going after this. Because otherwise, I just gotta reprogram it, and I'm gonna have to do that anyways. And it's so frustrating. I'd love to actually run something for once, but with my mistakes, might not happen. So for now, let's go ahead. Let's get this back to 0. I said back to 0. Okay, this now is wherever this is, which who knows, right? Also, this is whatever's coming out of that. Okay. I really wish I had the logic and the room for it to put the logic in for that. Because what you want to do is it needs an OR gate. Even a resistor gate would be okay. Because normally the processor will overcome it, right? In fact, just oh yeah. Oh, but that's what this is for. Did it come out? See, that's there so that I don't have output from that. It's supposed to keep it in the other direction. Let me see if maybe I'm doing it the wrong way. No, it apparently doesn't matter. What? Right, because if I pull this, we can see that that's where the grounds are coming from. If I use a pull-up resistor, oh no. We don't care about it. Let me try putting it down here. I really can't, because there's no room. But yeah, I mean, if I can't get the direction on this correct, what's the point? Let me go ahead and clock and see if that helps in any way. Okay, it does help. Okay, I found the problem. Part of the problem. Right, so, but wait. This is supposed to default to read. Okay? At the moment, it is clearly writing. Because I have, well, I was going to say I have nothing enabled. But if I pull this, oh, lights come on. Oh, you little... I don't know what to do. I really just don't. Okay, well, there's a lot more problems with this board than what I just within software. So I think the program's probably gone. I don't even feel like I can check it. So I'm going to fix this. And by next stream, we should be able to do something. I will also fix the stream. So you know what? No one's going to miss much. I'm going to save this file. We're going to do... I'm going to save this file and get everything done. But yeah, that'll be it for the stream. So, and maybe I'll do it a little bit later next time. 2's a little early. Maybe 3 or 4. So, yeah. Bye everyone who might be there, or maybe